Alright guys, so today is Module 3, Lesson 33. I can explain the connection of the area model of division to the long division algorithm. Reminders, area is the inside of a shape. The reason I'm choosing that is because eventually we will come back to area, and we've already done it a little bit this year, but this way you can remember. And for rectangles, squares, we find area by multiplying the length and the width together. So length times width times length, area. So we know that we could switch these for multiplication, and they wouldn't matter. However, let's take a look at this. This is kind of like a fact family, right? So I could say that 2 times 3 equals 6, and 3 times 2 equals 6, and they're both the same, right? Interesting. Now, if I know those are the same, I wonder if I can do it in reverse, where I have, 6 as the beginning. So can I do 6 divided by 3 equals 2? Yeah, because when I split 6 into 3 equal groups, I do get the number 2. Let me put an equal sign here. And then I could switch these, because 6 divided by 2, if I put 6 into 2 equal groups, I get 3. Huh. Interesting. So that means that I could write it backwards with division and find out like a missing side, where I have area divided by a side equals a side. So multiplication and division are opposites. Write an equation to find the unknown length of each rectangle. Then find the sum of the two unknown lengths. So this is where we came in, where we already have area, because area is the inside of this. So if area is the inside, and we're missing the outside, we know 3 times something gives me 600. And we know 3 times something gives me 72. So, well, the 600 should be fairly easy. Let's take a look. Well, I have 2 zeros, which means I should probably start off with having 2 zeros, because this number is bigger than this number. Well, 3 times what gives me 6? What was that one we just did? 2. So if 3 times 2 gives me 6, 3 times 200 must give me 600. So the side of this is 200. Now this one's a little bit trickier, but I think we can manage. Now, looking at the largest place value here, the 7, it is bigger than what we are dividing by. So I can rewrite this as 72 divided by 3 equals something. So let's take a look. We're supposed to be using the long division model for this, so let's go ahead and try that. Divide. Alright. Inside, outside. If I count by 3s, I'm going to get as close to 7 as possible without going over. 3, 6, stop. It's 2. Multiply. And subtract. Bring it on down. And bring it on back. Alright, 3, 6, 9, 12. So we got all the way to 12. So 4 times 3 is 12. Subtract. Nothing to bring down. So there's my remainder, which is 0. So technically we don't have one. So that means 3 times 24 is 72. Or 72 divided by 3 is 24. Put it up here. Then it says find the sum of the two unknown sides or lengths. 224 They're no longer unknown, but that's what we found. So if when I put these together, I get 224. Now, the point of that is, oops, I guess I'm not allowed to move these squares. I'm going to find a different color. So we found 672. If I were to put 672 together to divide by 3, I would get, so if I put these areas together, I would put these sides together and get 224. That didn't seem like a lot, did it? Because we split up the big number, which we knew we could get to easily because I can count by 3s to get to the 6. And then that only left me with a 2-digit number to do long division with. So that's interesting. Let's see if that always works. So it says use an area model and long division to solve below. I will be doing this one with you. You will be doing another one. So I'm going to split it up into 2 boxes just like I had it, right? Because that makes sense. But we're going to take a look at something really fast. That 9. Does that 9 make it an even or an odd number? Odd. Are odd numbers divisible by 2? Nope. So I'm going to go ahead and draw a remainder box, because I know I'm going to need it. But I am going to put 500 in here, and put 2 here. And I'm going to put 39 in here, and put a 2 here. So let's get started. So I know 2 times something gives me 500. Now, fortunately for me, 5 is bigger than 2. But unfortunately for me, 2 I cannot count up to and get to 5. So now I know that 2, 4, it's at least going to be a 2 here. But I have a 1 remaining. So now I have 100 remaining because I used 200. Because 2, 4. I used 400, sorry. Well, what's 2 times something gives me 100? 50. 2 times 50 gives me 100. So we didn't end up using both zeros because I ended up saying 2 goes into 50 25 times, and then I had a 0 here. But did you see that I didn't have to connect that 2 went into 50 25 times. I had to connect, well, I know I can get 2 groups of 2 out of this, 2, 4. So I subtracted not 4, but 400, because I'm talking about the hundreds place value. So look, now we're going to 39. So we're at 250 right here. I know that 2 times something gives me 39. But, I don't know without counting on my fingers and having to keep tally marks what it is. So when you're in a place that you can't count that high without taking you don't want to take a very long time, we'll do long division. We could also do the place value chart because of this 3, it being bigger than the 2. So we're going to put our 2 here. 2, let's count by 2 so we get as close to 3 as possible. 2, well, that was easy. Any more I'd go over. 1 times 2 is 2. Subtract is 1. Bring it on down. And bring it on back. 2, 4, 6, 8, 10, 12, 14, 16, 18. Stop. Any more, it'd be too high. 9 times 2 is 18. And subtract. I don't have anything to bring down, so what is this called? It's called the remainder. So remember how I said I was going to have a remainder? It means I'm going to have a remainder of 1. Which means this box is no longer 39. yet it's 38 because I took 1 away and put it into this little remainder jail because that 39 wasn't going to work. But then I'm going to bring this 19, put it right here. Here's my 19. Now, I can put, my original problem started off with 539. I can put it all together now. So I can say 539 divided by, so I add up these two. So I know I'm 0 plus 9 is 0, or is 0 plus 9 is 9. 1 plus 5 is 6. And then I have my 2. But then I can't forget about this guy right here. That pesky little remainder that we got to take with us. And then there is our answer. Let's try one more time. This time we're going to be doing area model and number bonds. So not long division, number bonds. So that's going to be nice. We're bringing that back, number bonds, to divide. So let's take a look. Would it make sense for me to divide this into 1,344? Probably not. So what I'm going to do is I'm going to put 1,300, and then I'm going to put 44. The reason I'm doing that is, one, that I have to do less math because I have less boxes, but I'm splitting my boxes into big numbers and bigger place values and smaller place values. So let's take a look. 6 times something gives me 1,300. I don't know my 6 places values off the top of my head. Do you? Nope. So what I'm going to do is I'm going to write them out. I'm actually going to type them out over here. There we go. Alright, so the reason I stopped at 60 is because that's 6 times 10. So if I was counting on my fingers, that's as big as I was going to go anyways, right? Does 6 look anywhere close to any of these numbers without going over? Obviously, there's going to be some zeros added. It looks fairly close to this 12, right? So if I know 6 times 2 equals 12, I know that 6 times 200 equals 1,200, or 1,200. So now I'm going to subtract what's left of my area model, because what I ended up doing was I did end up splitting this, but I ended up splitting it to make more sense in our heads. So I have 100 left because I went from $1,300 or 1,300 to 1,200. 6 times something gives me 100. Well, what I can do is I could add some of these numbers up to get close to 600 to 100. Well, right here I have 60, so I can start off with that. So I know at least I'm going to have a 10 here, because it's 6 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I still have to go bigger, right? So which one of these is going to get me to 100 without going over? Well, that's not going to be close enough. 72, 78, 84, 70, 80, 90, 70, 80, 96. Ooh, there we go. Because if I went any more, I'd be 70, 80, 90, 100, 101, 102. Notice I was counting by 10s for this digit and 1s for this digit. That's too big, so now I have a 3 times 1, or 6. 1, 2, 3, 4, 5, 6. But that only equaled 96. So when I did 6 times 16, it didn't equal 100. It equaled 96. Now remember, I can't go over, but if it equaled 96, not 100, I have something that starts with a R. What is that called? Remainder. And what is our remainder? If I have $100 and I spent 96, what's the remainder for? So I'm going to start a little box over here, put it in remainder jail. And I'm not going to erase it. I'm just going to mark it off and write, just kidding. It was actually 96. So I'll write my 200 up here. And my 16. And my remainder of 4 is already documented. Now, let's move over here. Make a line to separate my work here. 44. Well, fortunately, I already have my numbers here. So let's look as close as possible without going over. Well, 60 went over, 54 went over, 48 went over, 42, that one didn't go over, so 6 times 1, 2, 3, 4, 5, 6, 7. Whew, I didn't go far enough. 7. But it doesn't reach 44, does it? It only reaches 42. But if the whole thing has to equal 44, that means I'm going to have to put a little remainder jail off to the side, like a little annex, and put another 2, because 42 plus 2 is 44. Now, here's where the tricky part comes in. So now I got to recombine all these numbers. So now I know that 1,344 divided by 6 equals, I have a 200, a 16, and a 7. Well, add up my ones place, 0, 6, 7. 6, 7, 8, 9, 10, 11, 12, 13. So I'm going to put a 3, a 13, sorry. I'm going to add up my tens place. 1 plus 0 means I have a 10, not a 1 because I was working with the tens place. And then I'll do my hundreds place, no hundreds place here, no hundreds place here, hundreds place here, which means I have a 200, which means I could solve it out. 3, 2, 2. Now we can't forget about those pesky remainders. We've got to put those together too. 4 and a 2. When I put those together, I get 6. But am I allowed to have a remainder the same size or bigger? No, that just means the remainders would have ended up making it a group of their own. So instead, I'm not going to erase that because you guys probably wrote it because you guys are so awesome. That one, I'm going to put an X by because that remainder is not right because it's the same size of the original side. That means I could put this group together and this group together and make a whole nother group. Which means my real answer would be 224 with no remainder. I did that to show that if you ended up doing this and you end up with 2 remainders for whatever reason, maybe because your brain works like Mrs. Kohler's or just because of the way you split it up, when you put the remainders together, you still have to take into account it can't be bigger than the 6 or equal to the 6. Alright. You guys are going to do this one. Just this one. I'm being super nice because I've already kept you for 20 minutes just in my ramblings. Much less if you've paused like you're supposed to. Go ahead and do this. Set up your area model. You'll need 2 boxes. And I'll tell you at least the 5 goes here. and here. You have to figure out what goes on the inside. Oh, I totally forgot to show you number bonds because I said number bonds. This is what happens when Miss Kohler gets distracted. So, the number bond, I'll do an oval. Ovals are easier for me to write in anyways. The first thing I'm going to start off with was our 1,344. I'm going to split it into the two numbers that I made, which was, I'm going to write them backwards, 44. Another reason I'm writing them backwards is because the size of my circles that ended up, or ovals that ended up happening here, and 1,300. Because I know these two equal this when we add them. Now I ended up breaking this number down into I'm just doing it really fast version of what we already did. I ended up breaking it down into 42 and 2 because add these up gets me that. And then I ended up breaking this number down. Note that I'm just drawing one circle at a time. I'm not trying to draw all of them at the same time because that'd be crazy. Then I broke this down into 1,200 and 100 because that's what ends up giving me this. So when you add up all of these, you'll end up getting this big number up here. Go ahead and extend. Now when I'm dividing, now I'm going to end up dividing and putting this into groups of 6. So if I write divide by 6, I know I can't divide this by 6. I'm going to end up with 7. I have a 2 here. Technically, I broke this 100 down again. Into 96 and 4. I want to write this in a different color. I can't do anything with this, so this technically is its remainder, which this gave me 16. Again, I can't, this is too small for me to divide, and this one gave me, when I divided by 6, it gave me 200. But then, using this number bond, I could instantly see I have a remainder of 2, a remainder of 4, which I can combine these and just say, oh, here's another group. So I can mark them off and put a 1, and then I would just add 200, 1, 16, and 7, which would give you 224. Sorry, I should have explained that better, but I think you guys are probably feeling the brain overload as it is right now. So, after you break it down, go ahead and start off with your 438 at the top. And break it down into the two numbers that you've already decided to break your boxes into. Once you have that, just keep going as long as you need. Now I'm going to look at something really fast, and then I'm going to stop, I promise. Look at this 8. And I have a 5. What two numbers have to be in the ones value in order for us to be able to divide by 5 evenly? Remember, it was a 5 or a 0. This is not a 5 or a 0, so are we going to have a remainder? So we know we're at least going to have a remainder. I would go ahead and remember that. Alright guys, after you finish this one, I'm going to double check. If you don't get it, please don't hesitate to raise your hand, because I know this was a lot of information pounded into a lesson, at least 25 minutes worth. Keep it up, guys. After this, I'm going to have what problems you're working on the board, and then that'll be it. Bye, guys.